welcome back. Now we are looking at section 1.6, chapter 1, functions and limits, section 1.6, calculating limits using the limit laws. So far what we did was we found limits by plugging in values. Now that is one way of understanding what's going on, but that is not a proof. Okay? Using limit laws, we can actually prove our results. Let's see what I mean by that. We use the following properties of limits called the limit laws to calculate limits. Suppose that C is a constant. Okay, that is, pretend C is some number, 5, 6, whatever, constant. And pretend, suppose that the limit x approaching a of fx and limit x approaching a of gx exist. That means these are certain numbers. Okay, left hand limit is equal to right hand limit is equal to certain number, right? So that assume that, so that's a supposition or hypothesis for your laws, limit laws. Limit x approaching a fx exists, limit x approaching a gx exists. Then here are 5 conclusions. Limit x approaching a fx plus gx, so the sum of two functions also exists and it is equal to the sum of the limits. So notice what's happened. Limit of the sum is sum of the limits. Likewise, limit of the difference is difference of the limits. Suppose you multiply by a number c, just a c, that is its constant, so it is independent of x, then that c can come out. That's what this says. C simply comes out of the limit. Limit of product of two functions is product of limits, and limit of the quotient is quotient of the two limits as long as the denominator limit does not go to 0. Okay, this is very important. See, g of x may not be 0, but the limit may become 0. In which case, this rule does not apply. So this rule applies as long as the limit of gx is non-zero. Let's see how this is to be used. Okay. So these 5 laws can be stated verbally. Sum law. Limit of a sum is the sum of the limits. Difference law. Limit of a difference is the difference of the limits. Constant multiple law. Limit of a constant times a function is the constant times the limit of the function. So you take limit of the product, or you get the product out, the constant out, and then take the limit. It's the same. All right. Product law. Limit of a product is the product of the limits. Quotient law. The limit of a quotient is the quotient of the limits, provided that the limit of the denominator is not 0. For instance, if fx is close to L, gx is close to m, it is reasonable to conclude f plus g is close to L plus m. That's what we are using. That's the idea we are using. So, suppose here is your question, right? Use this picture. Find the limit of x approaching -2 of fx plus 5gx. Okay. Where is -2? There is -2. See, you understand the difference. F is the pink curve. G is the blue curve. And what can we say from the picture? What do we say? is at, let me write it down, looks like f at -2 is, here is -2, that's a whole, the value at -2 is +2, okay? But what is the limit as x approaches -2 of fx? The limit is given by the two branches and they approach height 1. Alright, so in other words, notice the value at -2 is 2, but the limit is dependent on what's happening nearby. The branches on both sides approach height 1, so that's the limit. Okay, what about g? G at -2, g gets you height -1. And what about the limit? Limit as x approaches -2 of gx, what happens to the branch on the left and on the right? Well, they all approach -1, so that's okay. So what do we expect this limit to do? Well, first, limit will split along the plus, right? So that's all we want to understand. First, it will split along the plus, find the limit of the first hand piece, which we already know is 1. And then for the second piece, 5 is a constant, so it's just going to be multiplied to whatever the limit is of g. All of this is happening towards -2. So that's a -1. Limit of gx as x approaches -2 is -1. So this is going to be 1 minus 5, that is a -4. All right. So let's see whether they agree with us. Right? -4. And they have said it in a much better fashion, right? They have found the limit each. For plus, it splits into the two limits. So this is what it means. Limit of the sum is sum of the limits. Now here is a constant law, right? Limit of a constant times a function is, constant comes out, and limit of the function. And now you simply substitute and you get your -4. All right. What do you think are the second questions? Well, the second question is asking us to find limit x approaching 1 of f times g. That's a difficult one. The law does not apply because as x approaches 1, g does not have limit. The two branches disagree. Okay. So at 1, we cannot use the law. Okay. In fact, we cannot find the limits at all. We can find right hand limit, we can find left hand limit, but not the limit itself because g does not agree. Next, the limit of the quotient, but this is going towards 2. At 2, g has limit 0, f has limit whatever, 1.5 or whatever. So notice g has limit 0. It's in the denominator. So again, the limits law does not apply. So let's see what they say, right? Right. X approaching 4 of 1 of fx is 2, but x approaching 1 of gx does not exist because the left and right limits are different. You see? So we can't use law 4. But we can use law 4 for one-sided limit. So let's look at limit from the left. So now you use the value of the left-hand limit of g, that's -2, and you have an answer. Likewise, limit from the right. Use the right-hand limit for g and use that value and you get limit of the product. Now notice the two limits disagree. So limit of the product as x approaching 1 does not exist. Okay. So we could find one-sided limits but not the limit which does not exist. Next, the quotient. So looks like limit x approaching 2 of fx is a certain number. Looks like 1.5 to me. They are saying it's approximately 1.4. That's okay. But the limit x approaching 2 of g, you see, that's 2. Height is 0. Either branch you come to, its height is 0. So we can't use limit 5. In fact, the given limit does not exist because we cannot take the denominator. We cannot have the denominator 0. All right. Here is another law, that is the power law. Limit x approaching a of fx to the power n is limit x approaching a fx its power n. That is, limit of the power is power of the limit. Okay. So this is nothing but, power is nothing but repeated multiplication. So this is a special case of the multiplication law. Okay. There are two special limits. One is the constant. Constant function has limit itself. Another is function x. When x approaches a, limit x is a. All right. Next are, so this is power, this is root, and which brings us to the root law. I will come to these laws in the next video. Until then.